On page 2, we're looking at 7 total points, 2 points for questions 6, 7, and 8, and just 1 point on multiple choice question number 9. And you're going to notice on number 8, it is 2 points, and it was either all 2 points or no 2 points. I did not give any partial credit on a few of these multiple choice select all that apply kind of problems. And the reason being is because on the Ohio end of year test, that Ohio State test, those questions are oftentimes scored as either right or wrong when it's select all that apply. There is no partial credit there. So let's take a look at question number 6. It says a line segment has endpoints with coordinates J at 1, -3 and L at 5, -2. The segment is rotated 180 degrees around the origin. List the new coordinates. So the rule on a 180-degree rotation is to take your x and y coordinates and turn them into -x and -y, or opposite of x and opposite of y. So 2 points. You got a point for each new point. The new j would be the opposite of 1 is -1, and the opposite of -3 is +3. So that is worth 1 point if you had -1, 3. And the new L, the opposite of 5 is -5, the opposite of -2 is +2. So the new L is at -5, +2. Those are your 2 points for question number 6. Question number 7 says write a congruence transformation or similarity transformation that maps triangle LMN. So we're going to start here with this one. And I have to turn it into the larger one. So the first thing I'm going to do is, this is one of those problems where I think dirt. Dilate it, rotate it, translate it. So the first thing I'm going to do is I'm going to look at segment LM. It is 1, 2, 3 units in length. Here is LM, so I'm going to compare that to UV. UV down here is 1, 2, 3, 4, 5, 6 units in length. So what must I do to 3 in order to equal 6? So 3 times what number equals 6? Divide both sides by 3, and I see that n is 2. So the first point here is I needed to see a dilation of 2. It has to get twice as big. And then I need to think about the orientation, reflect it or rotate it. If I were to reflect it, one of the things I'm looking at here is I need to get point L over here to point U. I need to get point M to point V. And I need to get point N over here to point W. So I can't just do a single flip. I would have to do multiple flips. Or I could do a rotation. I like my second translation here to be a rotation of 180 degrees. Now, I want to talk about this dilation of 2 first. So as I dilate this by 2, let me go ahead and put in my axes so you can see this. All right, there's my y-axis, there's my x-axis. And I'm just going to drag those points, the blue, red, and green, away from triangle LMN. So when I dilate by a factor of 2, right now, my blue point is at -2, +2. If I dilate by 2, that becomes -4, +4. So this comes to -4, +4. M is at +1, +2. If I were to double that, that becomes +2, +4. And M is at 2, 1, that would become 4, 2. So that's where those points end up. So let me write those. So this is 4, 2. And the green one is at 2, 4. And the blue one is at -4, 4. And remember, just like in the last problem, when I say that I'm going to rotate it by 180, my rule is change x and y sign. So this point here at negative 4, 4 should move to 4, negative 4. So I'm going to move it there. So 4, 1, 2, 3, 4, negative 4, 1, 2, 3, 4. You'll notice it lands right on U. So I can tell I'm going to be done, but I'll check the other ones. The point 2, 4 would become the point negative 2, negative 4. So 1, 2, 1, 2, 3, 4, and now it's on V. And then negative 4, 2, 1, 2, 3, 4, negative 2, and I am done. Those are the only two transformations. No translation is needed. I did have some people that said that they wanted to dilate by 2, reflect over the x-axis, reflect over the y-axis. That would also be fine. All right, but it was worth 2 points. I needed to see, I gave 1 point for the dilation, and I gave 1 point for the orientation change. So either double reflections or a single rotation, but there should not have been a translation anywhere. Question number 8 says this question is displayed on the smartboard. Use the space below to solve this problem. Put your answer in the space below. Show all steps to receive full credit. Select all that apply. So the first thing I'm going to do is I'm going to bring up what you saw on the smartboard. And it says triangle ABC is shown in the XY coordinate plane. The triangle will be dilated by 3 around the origin to create triangle A prime, B prime, C prime. So dilate by 3. So the first thing I'm going to do is I'm going to list these points. So A is at negative 5, 2. A is at negative 5, 2. Okay, and B is at negative 2, 5. B, negative 2, 5. And you'll notice I'm writing a lot of things as I copy from the smartboard. C is at 3, 4. Because this is exactly how I would do this if I were the one doing this. And then this says that I'm going to dilate by a factor of 3. All right, as I go back here, it says that it will be dilated by 3. Determine which characteristic of triangle A prime, B prime, C prime will be the same as triangle ABC. Okay, so let's go ahead and graph A prime, B prime, C prime. So dilated by a factor of 3. A is going to be at negative 15, 10. That's way too big for my graph. B is going to be at negative 10, A would be at negative 15, 6. B would be at negative 6, 15, and C would be at 9, 12. So this graph here really doesn't help me a whole lot, other than the fact of having negative 15, 6, and B prime would be negative 6, 15, and C prime would be 9, 12. But yeah, the graph here really doesn't help me. So the question becomes the coordinates of A prime. So are A and A prime in the same location? And absolutely not. All right, I can see that A prime is left 15 up 6. So this one is absolutely a no-go. B, the perimeter. Well, no, my image is 3 times larger than the pre-image, so the perimeters will not be the same. The area will not be the same because, again, my second triangle is 3 times bigger than the first. The measure of angle B, will stay the same because they will have the same shape, just not the same size. The length of a segment, they are the same shape, but they are different sizes. So that will not be an answer. And the slope of segment AC, it will keep the same shape. It will not be the same size, but it will be the same shape, so the slope will stay the same. So you had to have only D and F circled here. If you circled anything else, you missed credit on that one. You can only have selected D and F. And finally, number 9 says in the regular octagon below, oh boy, Which of the following is the minimum angle of rotation about the center point that will carry the figure onto itself? So if I'm thinking, what is to make this point land right there, how many degrees is that? And a lot of you said, well, find the order first. And I like that. I think that's a great idea. The order here would be 1, 2, 3, 4, 5, 6, 7, 8. So it has order 8. So the degree is 360 divided by the order. And if you do 360 and divide it by 8, you will get 45 degrees. So your answer is choice B, 45 degrees. That's it for page 2.